All right, so today we are compounding continuously. So what that means is instead of compounding once, a day or once a week or once a month, we're going to be doing it constantly. And some super genius found out that if you do that, the number is approximately E, which is that 2.718. The base is E, and it's raised to the rate, okay, where of course you insert it as a decimal. So this is just like the formula that we did in the past, but the base is never going to change. So we're going to keep E right there as that number in your calculator. P is the same. It's still the initial amount. R is still the rate, and T is still the amount of time. So R is your rate. It can be, just like if it was in one of the other formulas, it could be positive for growth, and it's negative for decay. So it's the same idea, it's just a different formula. So compounded continuously, you do tend to make a little bit more money, decrease a little bit faster, depending on if it's growth or decay. So you do have to know this formula again. We tend to call it PERT, and the word that you're always looking for is continuously. So if you see the word compounded continuously, that means that you are going to be using this PERT formula, where E is your base and your rate is now in the exponent. Okay, so compounded interest is a great thing, especially when you're earning it. Okay, it's not as fantastic as we like to say, but it is better than any other type of compounding if you're dealing with money. There we go, I just said this. So as an example, Nick invests $500 at this rate, compounded continuously. Find the amount of the investment at the end of 5 years. So we write our formula. So end of 5 years, time is going to be 5, and we know it's years, so that's good. And we put 500 as the principal, E is the base, the exponent is 0.075 times T. And then we solve it times T, which as we said was 5. So then we just plug it in, determine our answer is equal to $727.495. And they said to the nearest dollar, so that means A of 5 is equal to $727. Awesome. Next one, determine how long it would take for him to the nearest tenth of a year to triple his initial investment. So his first investment, his initial investment was 500, so triple means times 3. So that means that the final amount that we want is $1,500. So the formula that I use is this, 0.75T. And then you solve it. So remember, got to divide by that 500. And this is a 3. And this will always turn out this way. If I want to double it, triple it, that's the number that it'll be. So since I'm tripling it, that's going to be a 3. If I was doubling it, it would have been a 2. It's an interesting thing that if you know, makes life a little easier for you. Okay, so now to do this is E, so I'm going to use ln because I'm crazy like that. Bring this out front. So it's the ln of 3 is equal to, now ln of E is 1, so it's just 0.075T. So it's the ln of 3 divided by 0.075. And I get T is equal to 14.648. And to the nearest tenth of a year, that is 14.6 years. When they say nearest, they mean you're supposed to round correctly. Okay? Next. So this one, it shows a little decay. So the population of a bacteria is decreasing continuously at a rate of 1.2. Now, when we deal with population, it's quite often this formula, this PERT formula that we're going to use. So write a function to model this. So the function is, if they say function, remember you do have to make sure you write it in function notation. So this letter doesn't matter, but you do have to write it, with the parentheses like it's a function. Okay, so then it starts at 5,000. E Remember, it's 0.012 because we moved this over 2. But since it's decreasing, this is going to be negative 2 of time t. So just make sure this letter and this letter match, and we're good. So that's the function. So remember, it's negative here because it's decreasing. So if you have a decay problem that's decreasing continuously, you're going to use a negative rate, just like we always did, but now it's just in the exponent. Determine how long to the nearest minute it would take to have approximately 1,000 bacteria. So that just means we have 1,000 is the end. I started with 5,000, e to the negative 0.012, and that's time t. So I have an exponent here. When you're solving for exponent, we're going to use logs to solve. So solve it. I'll give you a minute to solve this. Well, I'll pause it, right, and try it on your own. Okay, so when we do this, remember, you have to divide by that 5,000 first. I get 1/5 or 0.2, doesn't matter. I made it used ln because ln makes e a little easier because that's 1 and it'll just go away. Bring that exponent out in front, and there it is. And all I have to do is divide by negative 0.012. If you hadn't made this rate negative, your answer would have been negative. So remember, if you ever get a negative answer, something went wrong and you got to fix it. Okay? You shouldn't get negative time ever. Okay, so 134 minutes is what I got, and that is the end. I hope you have a wonderful day.